All right, so I have some good news for you as we're getting ready to look at solving inequalities, which is similar to solving equations, except that we have inequality signs, so greater than, less than. The good news is this. With one exception, which I'll talk about after I finish showing you this first example, with one very small exception, solving inequalities is exactly the same as solving regular equalities. Nothing about how we isolate the variable and all that good stuff. None of that changes. So that should give you a nice big sigh of relief. What we're learning here today is very, very, very simple. Most of it is stuff that you've already learned this week. So take a look at this. Example of an inequality equation. Well, I shouldn't call it an equation. I should just call it an inequality. 3x plus 5x plus 10 is less than 18 plus 2x. Probably looks a little bit more scary than it really is. The first thing we want to do, remember, is we want to simplify our different sides of our inequality in the same way that we would simplify different sides of our equation. So over here on the left side, I asked myself, are there any like terms? And the answer is yes. We have a 3x and a 5x that could be combined to just be more simply 8x. And then we keep the plus 10 because that's not a like term. I'm going to bring down my sign here. Look at the right side. Is there anything that can be simplified? No. We have a regular number and then we have an x term, but we don't have anything, any like terms that we can combine. All right. Next thing we want to do is we want to isolate x. In order to do that, we need to get the x's on one side. So instead of having a 2x over here and an 8x over there, we need to consolidate. The way I'm going to do that is I could do it either way. I could move the 8x over here, or I can move the 2x over there. I'm going to move the 2x. I'm going to say subtract 2x from the right, and then I have to do the same to the left. That's going to leave me with 6x plus 10 on the left is less than just 18, because these cancel. All right, 6x plus 10 is less than 18. If I were solving a regular equation, which this is just like that, the first thing I would say is I want to get rid of the 10, because it's kind of the furthest thing out from the x. Subtract the 10, subtract the 10. I get 6x is less than 8. And then I finish this by dividing by 6 on both sides, which will give me a solution of x is less than the fraction 8/6. Or if you want to reduce, you can make that 4/3. In fact, I think I will do that. Make that 4/3. Okay, so we have a solution. Everything I did here, I solved exactly the same way as a typical equation. Now, they may ask you to say, can you solve this and then graph? What they mean by that is just take your answer and turn it into one of those cool little graphs we did in the last topic. So let's say I had to graph it. Here's my 0. Here's 1. 4/3 is going to be just above 1, so right about here. Oh, I don't want to make it a solid dot. I want to make it an open dot. I'm going to put the 2 here so we can see that. And it's x is anything less than, so anything to the left. And that is how I solve this. Now, I probably should write, I'm just going to write 4/3, because we should always label where we're starting. So this is 4/3. It's anything below 4/3. Pretty straightforward. Now I'm going to give you my one exception to the rule. And then we're going to look at an example that uses that. When we solve inequalities, something funny happens whenever we multiply or divide by a negative number. Now think about what happens just mathematically when we multiply or divide by a negative number. So let's say I had the number 5 and I multiply by -3. That would give me -15. Not only does it change the number, right, because I'm taking 3 times 5, but because I'm multiplying by -3, it changes the sign. It changes my number from positive to negative. Same thing happens if I divide by a negative number. When I do this using less than or greater than signs, something wacky happens in the math, and you will get totally incorrect answers if you don't flip the sign whenever you multiply or divide by a negative number. Now that's going to sound like, wait, what is she talking about? Let me show you in an example, and I think you'll see it's very easy to do, but the important part is to remember it. Now, just as a little side note here, some of you who are the type who are like love to ask the question, but why? I'm going to tag on a little extra video that's optional. So if you don't really care why this rule is important, then you can forget it. It's not life or death. But if that's going to really drive you crazy and you want to know why do I need to flip the sign when I multiply or divide by a negative number, you can check out that video, and hopefully it will calm your heart so that you can understand that it is all okay. We didn't just come up with this rule just to be crazy. So take a look over here. I'm going to give us an example. We'll do 5 plus 5x here minus 7x is greater than 2. So I'm going to solve this just like I would a typical equation. I'm going to start by combining like terms. 5x minus 7x is going to give me negative 2x. So that's going to give me 5 minus 2x on the left is greater than 2. There's not much I can simplify over there. Now we solve. I'm going to get rid of the 5 first because it's furthest out. Subtract 5, gives me a negative 2x is greater than negative 3. Now here's the big, I'm going to put a big star. Here's where our problem could happen. When I go to isolate the x, I'm going to divide by negative 2, right? Because I want these two to cancel. As soon as I do that, two things are going to happen. On the right side here, I'm going to end up changing this. It was a negative number, right? Negative 3, but I'm dividing by a negative number, so now this is going to turn into a positive. Negative divided by a negative is a positive, so this is going to become just 3 halves. This is x over here, so we canceled these. The second thing that needs to change is instead of this being a greater than sign, this needs to flip and become a less than sign. So whenever you multiply or divide by a negative, you always switch the sign. So I'm going to say switch the sign. And I don't just mean over here like positive to negative. I mean this actual less than or greater than sign. We would graph this out if we were asked to. Here's my 0, 1, 2. This is our, right here would be my 1/2, or 1.5. And then it's anything less than. So I would complete the equation. What does that mean? Well, it means that any number in here, if I plugged it into the equation, should give me a number on the left greater than a number on the right. If I were to plug in any numbers up here, it wouldn't work. But any numbers where the arrow passes, so down here to the left, any of those numbers should make the equation true. So just in case you're doubting me and you're like, I don't know about this whole switch the sign thing, let's choose a number that's down here. Let's choose like negative 1 and see if it works. If I plug in the negative 1 for x, do I get a true statement? Well, that would give me 5 plus negative 5, so 5 minus 5, minus negative 7, so that would be plus 7, should be greater than 2. Does it work? 5 minus 5 is 0, plus 7 is regular 7. Is 7 greater than 2? Yes, it is. That's awesome. So we got the correct answer. So what's the big thing that we need to remember? Whenever we multiply or divide by a negative number. So it's not just when you multiply or divide. It's when you multiply or divide by a negative number, you have to flip the sign from either greater than to less than, or the other way around, from less than to greater than. Otherwise, you will get totally incorrect answers, and you'll be so disappointed. Addition and subtraction doesn't matter. Multiplication and division is the only part that matters. So if you are content with that explanation, you are done with your homework. But if this is going to drive you absolutely crazy as to why are we flipping the signs, I have a short little video at the end of this that you can take a look at, and hopefully it will ease your worries. All right, see you tomorrow.